This lesson's about enzymes, and here are your objectives. Enzymes are biological catalysts, meaning that they speed up reactions without themselves being consumed, and so they can be used again and again. And the structure of enzymes is key to their function. They have a site on them where substrates, meaning the molecules that are going to undergo reaction, bind, and then catalysis occurs. And that site is called the active site. So imagine that you have your enzyme here, and it has a particular region with a specific shape. And that shape is going to match the molecule that it's going to bind. So this in green might be the molecule that it's going to bind, and this here is the active site. So the substrate binds to the active site, and then the reaction happens. And that might be that this substrate is bonded to something else. It might be that it's broken down. The fact that the active site matches the substrate gives the enzyme specificity. We talk about substrate specificity. And that in turn led to the idea or the model of enzymes and their substrates as locks and keys, or the lock and key model. However, it seems that that model is actually probably not the most appropriate for most enzymes and their substrates. And in fact, we have what's called more of an induced fit model. You can think of this being like a handshake, where the enzyme active site and the substrate shape don't necessarily match exactly to start off with, but as they come close together, the substrate changes the shape of the enzyme in the active site so that it fits more completely. Also remember that enzymes are dependent on their three-dimensional shape for their function, and so they can be denatured. Remember, that means that their three-dimensional shape is changed by an alteration in temperature, so very high temperatures, or a change in the pH. And if they're denatured, they lose their shape and therefore their function. So we've said that enzymes speed up reaction rates by a lot. Let's consider that further. First, how do you actually measure a reaction rate? Well, you could look at how fast the products are appearing. So if you were to look at the concentration of the product over time, then you might see something like this. As time goes on, more product is formed. This might be a fast reaction. You could have a slower reaction where less product is formed for every unit of time. You could also look at how the reactants were disappearing. In that case, you might see something like this as the reactants are disappearing in a slower reaction, and this as the reactants are disappearing in a faster reaction. In all of these cases, the slope of this concentration versus time graph is giving us the rate of the reaction. A steeper slope is a faster reaction, and a less steep slope is a slower reaction. Bigger value slope, faster reaction. Smaller value slope, slower reaction. Now if I take those slopes though, and I were to graph them against the substrate concentration, I see an interesting thing happen. First of all along here, this is all at one substrate concentration. So this is one experiment, and that experiment might give me a value like this. So I'm taking the slope here and I'm plotting it as a point as the rate of reaction at a particular substrate concentration. Then I increase the substrate concentration and I run it again, and I might see that I get a faster slope. So in this second case, I'm getting something like that. Then I do it again and I get a faster slope still. And I will tend to see that increasing rate of reaction as I increase the substrate concentration for a while. And that's because what's happening is there's just more raw ingredients, more substrate available for the enzyme to work on, and therefore more product formed. But after a while, it starts to flatten out or plateau. And so you see an overall shape that looks like this. What's happening there is that at a certain point, you're running out of available enzyme, and we say that the enzyme is saturated. The enzyme being saturated means that every enzyme's active site is being occupied by substrate, and so adding more substrate doesn't make the reaction go any faster because there's just no more available enzyme. So that's an introduction to the structure and function of enzymes, active sites, and reaction rates.